So I'm sorry that I'm up again. So it's my last presentation. So it's and you had a coffee break, and so I think after the Siemens presentation there was a question about what kind of information models do you support in your product. I think there's always the built-in system model that a product normally supports. So if you have like what was the motor starter, there is no information model defined for motor starters, and so what you typically expose is what you have as internal information, or at least the part you want to expose. So it's more or less the information model of the vendor that provides the product. And it's the same like for a SCADA system. If you expose just the internal data of a SCADA system, it would look like the model that is inside the system. But we're talking about standardized models, and it's probably a challenge for product vendors to support these standard models, but that's another story. But we just discussed in the break about like the information models, and this is let's say the long-term goal is to create interoperability on the semantic level. It's nothing that happens immediately. It's a lot of products are happy that they have OPC UA connectivity integrated as a first step, and the modeling capability is something that will be enhanced over time. So you should not expect to see all OPC UA products have nice modeling capabilities in the first version. And the main reason for that, especially if you have existing products, and this existing product has no object-oriented internal capabilities, it's maybe something you have to add to your product first before you can expose such features through OPC UA. And changing the product for an external interface is not an easy step. So then there must be some strong customer demand for that. And so therefore, this whole modeling capabilities is nothing that will be, you can benefit like tomorrow from. That's the long-term goal, is to create this semantic interoperability. But there are a lot of different areas, and so that's why we work already on these standards and companion models to provide a good baseline for further development and product integration. There are like two main variations of information models that we create. One is, and that's like with Automation ML and a few others, if there's already a formal description of that model, could be UML, could be XML schema, could be like EDDL for device description. In this case, we just define transformation rules. So how to transform the one description model into an OPC UA model. And in the best case, and I think that what happened with Automation ML is there's a tool that is doing this transformation automatically. So if you have an Automation ML project, you can create an OPC UA model just with running a tool. But at the end, after transformation, you have like a model, machine readable model file, and the specification. And the other way is you have just knowledge of domain experts, but no formal description of this knowledge. And in this case, this formal description is directly created in the OPC UA format, in the OPC UA schema. And then the result is again a model file and a specification that describes more details behind it. And so before I go to the AutoID, I will give you an overview, especially also about base specifications we layer on top with the AutoID specification. And one of our base component specification is OPC UA for devices. And it's in the first version, it was just a device configuration model. So it was the first step, the device model that was already released in 1.0, and it's like more or less a standard way to expose device parameters, to group device parameters and configuration commands. With FDI, field device integration, I will talk about that just in a minute. There was they layered on top of the DI model, but they extended a lot of functionality that is necessary to do like a network configuration, but also the concept of having an offline configuration in a central place and do an online-offline exchange and update between the device and the offline configuration. And so since the definitions from the FDI working group were like more generic and can be used in other use cases too, the FDI working group agreed on moving these models, or most of that, from the FDI specification to the DI specification, and that was then the version 1.1 that was released in July 2013, and is now also available as IEC specification part 100. And so the device communication model was added, and the device integration host model with this online-offline capabilities. There was a working group working on analyzer device integration, so that's very special devices, process analyzer devices. And they also layered on top of, we have a laser pointer there. They used the device type defined by the OPC devices specification, and they created very specific device types with huge, like even state machines for operating devices. So there's a lot of definition for such process analyzers, and they just updated their specification after the release of the OPC UA DI spec to 1.1 because they got a lot of implementations based on the version 1.0, and they had also fixed some issues they found with the implementation. So another, and I mentioned that already, another working group that is using OPC UA for devices as basis FDI, field device integration. The concept there is that you describe a device with a so-called device package. The device package contains like the device parameters, business logic, and user interface description or user interface elements. And so the FDI server loads the device package. So like you have a device type tree where the import creates like a type in the FDI server, and if you create an instance of that device and configure the device, you can do also like a download of that configuration to a device using any of these field buses. But the key thing is that the model inside the FDI server follows completely the model defined by OPC UA for devices. So if you import a device package, it creates an OPC UA object type. If you instantiate a device and configure a device, you create a device object following a OPC UA device object type. And then the communication between the FDI server and FDI client can use OPC UA as a client-server communication if it's separated client and server in FDI. So this FDI specification is also now released as IEC specification. And that's the reason, this IEC is the reason why we also released OPC DI as IEC specification, because you cannot reference non-IEC specifications there, at least not for basic functionality. Another working group that is layering on top of OPC UA for devices is the FTT working group. So it's also device configuration. They have a slightly different concept than FDI. Sorry, it's in FTT you have I think it's called device type manager. So you have a programmed component from the device vendor, and you have a frame application that hosts the programmed configuration component. So I apologize for all the experts of FTT and FDI here, but it's the key thing is the working group works on an OPC UA server interface on top of this FTT frame that would expose all the device parameters and configuration options and information about the device, and also the online-offline functionality through an OPC UA server following the same exact DI model like FDI is doing. So it's from a high-level view from OPC UA client, you will get similar information from a FDI OPC UA server or from a FTT OPC UA server. And this working group is working on a prototype at the moment. They have, I think they want to do a demonstration at the SPS IPC Tribes. So there's a lot of stuff already working and defined. Automation ML, I will skip that. Vera will talk about that. PLC Open is IEC 61131. It's also one of the older companion specifications. The first version, I think, was released together with OPC DI 2010 already, so it's a long time ago. And the first version was about exposing the software objects in the PLC, so function blocks programs, in a standard way to OPC UA clients. So the PLC programmer is by declaring function blocks and instantiating function blocks is more or less creating the OPC UA information model. So that was the first release. So that allows being a PLC or OPC UA server and having client access from HMIs, from MES to the server, to the PLC data. In a second step, there was a working group was working on so-called client function blocks for PLC. So we defined like OPC UA connect, OPC UA read, OPC UA write function blocks so that a PLC programmer can initiate OPC UA communication out of the PLC program. And so that was released April 2014. And so now a PLC can be, in a standardized way, expose its own objects through OPC UA server, but is also able to communicate with other OPC UA servers by programming these function blocks inside the controller. So the PLCs can be client and server, and especially the client functionality is used for controller-controller communication, but also MES connectivity, especially calling methods on the MES API is a very popular feature there. And the working group is currently working on extending the function blocks with more features and more functionality. So this is a very active working group and one of our oldest companion working groups. And like from there you can also see how such standardization drives adoption and also pushes other, because like the PLC working group was very important, kickoff for the PLC vendors to get a common understanding on how to integrate OPC UA into PLCs. And so that brought new use cases like what I said, the function blocks, to be able to call methods on the MES system, and the wider adoption of OPC UA in PLCs. And that now drives also device vendors to think about, okay, there's OPC UA is a standard API to PLCs. So how can I use that? And that triggers really this AIM AutoID working group that I'm talking about now. And so there, AIM is the organization that manages different standards for AutoID. AutoID means barcode readers, one-dimensional, two-dimensional, RFID, or RTLS is real-time location systems. So you can ask the system, where can I find this piece in my plant? And their use cases is one is the connectivity of such devices to controllers. So like in a production line to scan labels of products, but also the integration with MES with IT systems. And like in their world today, they have to connect to all these kind of different systems, and they use either like field buses, but the kind of information they provide does not fit a field bus data transfer. So what they do is they layer a protocol on top of a field bus. So you always need special function blocks in the controller to talk to such a device. And it's different for every device. And the same like for IT integration, you have always different API, vendor-specific APIs, vendor-specific protocols to talk to such devices. And so their concept when they came to the OPC Foundation was, okay, can we use OPC UA as a common communication platform for our AutoID devices? And we told them, sure, no problem. So that was a slide where they came to us and told us, okay, is that possible? Can we do that? And the working group has now a release candidate. So it was, I think, one of the fastest working groups we had ever. From the initial starting point to a release candidate was less than a year. And the basic concept is they also layer on top of the device model. So all the DI-based functionality to configure a device is available for such devices. And then they have the AutoID specific APIs, like a AutoID device type. You can have a configuration file, but the main functionality is to have a scan method. So to have a direct scan, like from if the PLC has a sensor that detects a new product, and then can trigger the scanner to scan the tag of that product. Or there is a scan start and scan stop. So it starts scanning, and then the device can send events, AutoID scan events with every detected tag. Or the device can just operate in asynchronous mode. So whenever it detects something, it can fire an event, new tag detected. And so this is really the model consists of the device type, methods for synchronous scanning or asynchronous scanning, and the events for inform a client about asynchronous notifications of scanning results. There are different types for different device classes. So there's an optical reader device type. And the optical verifier, there's a slight difference. Like a reader is just a regular reader of a tag, and the verifier it's a device that is used directly after writing the tag. So they check the quality of the tag. So it requires more information than a normal reader about the quality of the tag. Then there's an RFID reader, OCR reader, and this RTLS real-time location system devices. And there's currently also a request to support writer devices, so that you can also like write optical tags to the same interface. And then the corresponding event types, so optical scan event, RFID scan event, OCR scan event, and RTLS scan event. The most complex device are the RFID reader devices, and they have, in addition to the scan methods, they have also access methods to there's always a memory area related to RFID tags. So you can read and write data from the tags. And these are the methods like read tag, write tag, but there's also like you can kill the tag, you can lock it, or you can set a password on it. And this functionality is also exposed through OPC UA methods. Okay, so that's the information model, and the status is that the working group is currently working on the prototyping. So it has incorporated all the review commands from the release candidate phase, from the release candidate review, and now is working on the prototyping to make sure everything can be implemented. And the goal is to release that specification for the Hannover Fair 2016. So it's in the final steps. And there's a huge interest in that. We had, like in the last meetings, we had I think around 30 device vendors joining the working group. Okay, ISA 95, I think there's another presentation about that. BACnet is building automation. We did a mapping of like all the BACnet objects to OPC UA object types, BACnet events to OPC UA alarms, BACnet logging to OPC UA historical access. And the biggest challenge was to do all the structure and union mapping. So I'm not sure if anybody worked with BACnet before. They have tons of data structures and unions, and especially the unions forced us to add this feature to OPC UA. But unions, yeah, it's you can model unions like with classes and derived classes, but with the number of unions they have, it would be complete overkill for the type system. So we decided to add this feature to OPC UA. And by the way, it's also used now by the AutoID working group, so they already had use cases for that. But the main idea here is not to reinvent BACnet, is to provide a connectivity between building automation and industrial automation. So there's a need for integrate these systems. And like there are OPC UA servers for BACnet already available. Like Kepler has one, and I think Siemens also mentioned that the WinCC open architecture is as a BACnet driver and OPC UA server. But the idea here is that you have a standardized mapping model from the BACnet model to OPC UA, and if you buy OPC UA servers from different vendors for BACnet, you get always the same look and feel and mapping. And so this is one reason that what was interesting for the BACnet community was also like the MES and IT connectivity. So what they really pushed them was that SAP has already OPC UA client functionality available. So that was a use case for them. We heard this morning already about, how much time do I have left? So, okay, perfect, no problem. We heard about oil and gas and MDIS. Stefan said you were aware of MDIS. Who knows what MDIS is? Two, okay. MDIS, yeah, I'm not surprised. It's a working group that was started, I think, 3 years ago by all the major oil companies. And they wanted to have a standard communication interface between subsea production equipment and the DCS system. And so they involved like all major DCS vendors and all major subsea vendors into this working group. And they invest a lot of money in verifying different protocols and different communication platforms. Even Modbus and classic OPC and Profinet and Ethernet IP, though they had 10 different variations that they tested. They had a company that really tested every single protocol for the requirements. And at the end, it was decided to use OPC UA. And since then, the working group worked on modeling such subsea equipment like valves and as OPC UA models, and they, I think they did first interoperability workshops, so where they had really subsea equipment DCS vendors meet together in a plugfest environment and did already first testings. So this is real already. It may take a while to really get the products released, but the oil companies are really pushing hard on the DCS vendors. And subsea vendors, they have already implemented OPC UA, some of them since years already. But on the DCS vendors, it's the oil companies now increase the pressure a lot. So that's a very interesting companion working group that really pushes the OPC UA into the oil and gas business and increase the demand there. A completely different story about machines. there was one working group that's VDV, is a German Association for Machine Tool Vendors, and they created a working group between controller vendors, numeric control vendors, and machine HMI vendors, or mainly the machine builders that build their own HMIs. And they wanted to standardize the API between the numeric controller and the machine HMI. And they finished the first specification already, and I think they will make that publicly available now. I think they have an event now in October where they want to make that public. Euromap 77, that's injection molding machines. They decided for their new version of their MES interface for injection molding machines to use OPC UA. And that was initiated by the German VDMA, but it's already now accepted as the proposal was accepted by the European level, so Euromap is a European standard, and it's normally also adapted by the US then. So they agreed on doing that with OPC UA, and the work is now officially started, and they're working on all the details of exposing data from a machine to MES. And something that is a new initiative. There was a kickoff meeting, and they discuss now to use OPC UA also for the connectivity to handling machines, like robots, between injection molding machines and robots. And that would require the new OPC UA pub/sub real-time functionality. But the machine vendors push for that, and also robot vendors like KUKA, which is a small one, but I think important one. So they push for OPC UA there, and I'm not sure if this is already decided on the European level, but it looks like that would be the proposal to use OPC UA there. Okay, there's more, like in the field bus area, Stefan mentioned already Circos and EtherCAT. You will see much more announcements at the SPS IBC drives, and more coming after. So we are in discussion with nearly all of the groups about collaboration. In the smart grid environment, we have a working group 61850 mapping to OPC UA. In the oil and gas area, there's more like MT Connect for machine tools, and even like early discussion with kitchen tool manufacturers like washing machines and heaters, and to integrate OPC UA in industrial grade devices there. So there's a lot of activity around these information models. Okay, just to summarize up, information modeling is a key feature in the future for OPC UA. It allows the semantic interoperability, and like I said, it's the long-term goal to create this semantic interoperability. And it's at the moment, there's a large number under development, and now we try also like to get some classifications, like what can be used as a base model for machine interfaces, to not always reinvent everything, so to find similar things across different machine types. So that's a challenge that we're working on at the moment. Okay, thank you.
Questions about modeling? To me, it seems that every time I hear Matthias talk, there are some new working groups started, especially this year. I lost count how many have started. It seems that the pace is now accelerating with this collaboration work. So far, most of the work has been concentrating on the base level kind of making OPC UA available in general. Nowadays it seems that we are in the status that the base technology is working, but now we are working on this collaboration, and it's extending so fast that I'm amazed myself all the time. no more questions, thank you.